G'day guys, it's Galvin, Cartoon Company in New Zealand. I'm here at Head Racing Engines, HRE. I'm going to catch up with Glenn Head, and this is where little engines come to grow up and be big boys. This is the sort of stuff that he's got hanging around. Stuff like this is normal here. This happens to be his own boat. We'll ask him about some specs on that one. And we're going to check out his dyno. There seems to be a habit here that everything has to have 8 cylinders. And of course, it's one of my preferences too. They've got to have 8 to be a real engine. So I met Glenn quite a while ago, and he was referred to me by another guy who some guys might know, Jace Brown, who happens to own a UZ powered drift car. And Glenn needed a tuner. So he came to see me, and a few days later I was strapped in a sprint boat with a laptop on my knee, tuning one of his older boats. And he went on to win the World Championship, because he set a goal to, and is undoubtedly one of the best sprint boat drivers in the world. I believe his goals a little bit have expanded, and now he has some goals of building some super cool, super powerful engines and making them reliable and helping other guys go really fast. And you can kind of see it in his plan. He'd put the dyno in a couple of years ago to help with his goal on his own boat, and now it's become part of his business moving forward. And that's what we're going to talk about today. We're going to chat about his dyno and the engine that he's just set up on it, making pretty reasonable power. I've been helping over the last couple of days, and it's great to see the process, and we work really well together. Glenn, how's it going?
Calvin, how are you?
Good.
The story?
Let's check out this dyno of yours.
Yeah, come on in, have a look. So we've got a land and sea dyno. It's capable of about 2,000 foot-pounds of torque. Yeah, we're giving a good test with this motor that we've got on here at the moment. So this is a motor I've been doing for an American customer, Kyle Patrick, for a jet sprint boat. It's a 430 cubic inch small block Chev based engine. It's twin turbocharged. It's got my whole camshaft package, valve train package. It was all his existing turbochargers, exhaust manifolds. Since we've had it on the dyno, we've changed basically the whole fuel system. Runs a 4-stage dry sump setup, and at the moment we've been around 15 to 18 pounds of boost. The motor makes a genuine 1,500 horsepower, a good 1,200 foot-pounds of torque. So they're pretty impressive numbers. Yeah, we're really happy with how this thing's come up. So,
And time with this engine on the dyno, of course I was here with you, but running methanol, so running alcohol, how much fuel did you put through that engine whilst on that dyno?
yeah, so we've run it over 3 days. Had a few issues that we needed to sort out. If you turn around behind you, you'll see the empty drums, as well as most of the way through this one here. So it's a time-consuming process, as you know yourself. But once you get it right, it just becomes a real sweet thing.
That's right. I came in and Glenn asked me to tidy up the loom, and this loom was lovely. It was built originally by Motec, or the guys from Motec built it. I gave it a bit of a sort out, but there were some existing problems that we had to find. So running through the dyno process, it was strapped on. We put the loom onto the engine, or the harness onto the engine. It's been converted to individual coils, running an M800 ECU. The coils are wired wasted spark. And up top, we've got some Siemens injectors. So they're pretty big squirters. There's over 2,000 with 2,000 cc's of injector per pot up in there. We got it on and we got it running. Straight away we brought it up to 3,000. First problem we came across was it was running out of fuel. So tell us about that.
Yeah, so normally when we get a motor like this on the dyno, we do a lot of static tuning. So we run up through a static RPM and we load it. So with this motor, we were running most of the existing fuel system that Kyle would supply us with. So once we started getting up to like 3,500 revs, started having problems with fuel pressure. And at that point, with a motor like this, we're already making 800 plus foot-pounds of torque. So the demand on the fuel system, even though your RPM isn't there, is still huge. So we replaced it for a bigger pump, so it's got a 10.4 gallon per minute fuel pump on it, which I suppose at 8,000 RPM, which we don't run this motor to, the fuel system on this motor is capable of processing 40 litres a minute. So everything's got to be right when you're talking about those numbers, and like Calvin said, the Siemens injectors 2,400 cc's each, and we run quite high fuel pressure, so they actually flow a lot more than that.
Yes, because I think the Siemens are rated 2,200 pounds or 2,400 cc's at 3 bar.
Yeah, that's right.
And we run them up, we're maxing at about just under the 90 psi. 86 is sort of the top PSI I was seeing, so you're probably flowing about 4,100 cc's through those injectors.
Yeah.
So we got the pump done, running up, and of course in this engine it runs individual exhaust temp sensors for every cylinder, and we've got history on this engine, so we've seen this setup, this management, we've got some history. And we had some inconsistencies with cylinder to cylinder and bank to bank balance. So what was the next thing once we've done the fuel pump, Glenn? We moved on.
Yeah, so once again, we used a lot of existing components from Kyle's fuel system. So we had his fuel injectors out of his motor, and we were having problems with them. We changed a couple of them around to prove that we did have issues with the injectors we were using. They were the same as these fuel injectors, so we decided to change out the fuel injectors. I had another set sitting in my boat, so we put these ones in, and we've got rid of the problem 100%. So that sort of shows that with a methanol motor, how important it is to maintain and clean your fuel system, because what had happened with this one is they were getting blocked, injectors were staying open, and so we had a mixture of not only hot cylinders but also cold cylinders. And then once we put on a flowed set of fuel injectors, our pyros run now up into the high boost numbers within 20 degrees Celsius of each other, which for a motor like this is pretty impressive. What that does is it means that when you're running your two oxygen sensors, one on each side obviously, it means that you can get an extremely accurate reading off those sensors, because your cylinder to cylinder distribution is so accurate.
Right, with the injectors done, running it up, and it came up good, but of course we could see, because we could test it on the dyno, we could of course see that there's some issues happening. So after the day two, at the end of day two, you sent me to bed and said I had to find where the voltage issue was. So that was the mission for today.
Yeah, so yesterday we had some problems, and it wasn't until we sat down after we were running the motor that we sort of looked at some data and decided that not only was there a problem with voltage, but a historic problem. So that was what we spent most of today doing, most of this morning doing, was rerunning earths, rerunning power supplies, trying to stabilise the voltage in this thing, because obviously what happens when you start losing voltage is you start losing control of things, and obviously the power that's getting to things to open and close or actuate or do whatever the power's needed to do. So it was a bit of a process that we had to go through to eliminate a few things, but once we got on top of that, it was one step forward and then once again 2 steps backwards.
So of course, we got some voltage. Voltage was happening, and we started pushing it higher in the revs, and we had a cylinder that kept dropping out, and you could see it with the power curve.
Obviously, one thing we've changed on this motor is we've gone from a magneto MSD distributor as the ignition source to individual coils. As Calvin said earlier, we're running wasted spark on this thing. But we found something as simple as that we didn't have enough dwell time in the coil setup to fire the amount of fuel that we're putting into this engine.
With this ECU, often we would run an ignition expander so we could run individual coils. But I opted in this case to wire it wasted spark. So it fires 2 coils, 2 cylinders at once, one at bottom dead center, one at top dead center. And that means we didn't have to put extra components in it. It was very simple for me to add the coils to the loom. But we were having problems that number 5 cylinder said, I've had enough. And it was at the same point, and both of the data on the dyno and on the ECU on the laptop coincided at the same point on number 5. So we had to make a decision. Glenn, to solve that problem, of course, we did a couple of checks. We pulled some info out of your boat, compared the dwell figures. We put it in, and what happened as soon as we put some good dwell up it?
Oh, hey, as soon as we got some good charge time on those coils, the thing came to life. You know, one thing with these alcohol motors is that, like I said earlier, you're putting so much fuel into it that the energy required to ignite it is massive. So we obviously missed something earlier on in the setup of the ECU, and I mean that's something that happens with these jobs. But you know, we sort of bashed our heads together and figured out what was going on with it, and once we did figure that out, it was pretty smooth sailing from there on out.
I actually think there was some pretty massive smiles, because straight away it just rev clean, and power figures, they just skyrocketed at that point, didn't they? They just went straight through.
Oh, I mean, that's right, and that's one thing with it is you know, you get motors that are misfiring, and not only does it upset the motor, it also upsets the dyno that's trying to hold the motor. So with this dyno, it's all electronically controlled loads. So when you get a misfire and a drop in torque, it then drops the water flow to the brake. But then when the motor then fires again, because it's got a drop water flow, it has this whole thing that just argues against itself, and it chases its tail, and it's just a bad recipe. But yeah, once the thing was running sweet, it came up really nice and really smooth. So we got some really good numbers out of this thing.
Glenn, we're standing by your engine and your boat, and it's a little bit rated because we were fixing Kyle's. Comparing your engine to Kyle's, what do you reckon?
Oh, hey, they're a little bit different. This is quite a bit smaller motor, so it's got a little bit less stroke. The whole bottom end on its billet, so we use a custom-made billet block, billet crankshaft, billet conrod, billet piston, probably slightly smaller cylinder head. This motor does run quite a bit more compression, so it's a different dynamic beast, but you know, very similar in terms of the potential of the engine. being such a strong bottom end, we can run this engine quite a bit higher in the boost reliably. So this will make around 1750 horsepower, about 1500 foot-pounds of torque, but that's up around 22 to 25 pounds of boost. So yeah, the similar engines, but a little bit different. The compression and the individual throttle bodies will make it quite a bit more responsive, but also add some more restriction at full throttle. So yeah.
Well, it's going to be interesting to see how they compare at the end of the day, because that's a grouse bit of kit right there.
Oh, too right.
And I believe there's a secret squirrel new one happening for yourself.
Yeah, so we've sort of worked out what worked and what didn't work with this engine. So the new one is similar size to this one, so it's still a smaller motor, but we've gone a whole lot bigger in the intake manifold and a little bit of a redesign of that as well as a whole lot more cylinder head. So the potential for that new motor is definitely going to be a whole lot higher.
Yeah, I'm really looking forward to seeing that new motor up and running, so that's going to be a cool bit of kit.
So am I.
Yeah.
One day.
Excellent. So this engine now, what's the next plan for that engine?
So the next plan with this is we take it from the dyno and we install it into the boat, and then we do all the fine tuning of it. We can do a very accurate tune on this motor on the dyno up till around 4,500 RPM. Once you start getting over that, the power you're generating, the heat you're generating, really limits what you can do on the dyno with a motor like this. You can really do short power runs well, and you can get some really good data from that, but you can't do long sustained runs with the amount of power that you're looking at making. So we'll take it from here, we'll put it in the boat, and then we'll go and do some runs around the track or on a river, and we'll get some really good data from that, and we'll finish off the tuning of the ECU from there.
That's right. And just on the temperature, of course, we came in this morning, this engine was at 40 odd degrees.
Yeah, I think so.
From the water running through. Just tell us, outside this room there is a big water tank. How big is that water tank, and how hot do we get that water?
Yeah, so we've got a 10,000 litre water tank plus another 1,000 litres sump tank in the ground. So say 11,000 litres. So with a motor like this and the sustained runs that we do earlier on, I think yesterday we saw the tank at about 65 degrees Celsius. So you wouldn't want to hop in it.
No. And it's phenomenal the amount of heat that it's generated. It's just amazing. Well, it's been a good process. I think you're happy with the results. I'm happy with the results. And I think the owner's going to be bloody happy with these results as well. And it can be put in the boat and head back home to the US of A and show the boys over there how the Kiwis build an engine.
Bring it on.
Great talking to you.
Cheers, Kelvin.
Thanks, mate. Good one.